in parallel here. So we are fortunate. And this is, by the way, our crowning seminar, meaning the last one. And we are fortunate to have my friend Alan Gorin from AT&T. And Alan Gorin got a PhD degree from the City University of New York under Shmuel Vinograd, if anyone knows who that is. IBM fellow, a very famous person. And then he said he worked for a short time in Lockheed and then went to Louis Gasset also worked at Lockheed. And then went to AT&T and worked on parallel processing. And then he saw the light and decided to work on spoken language processing.
Yes.
And he is the author of the famous How May I Help You system, which is spreading around as a product. And he's going to talk to us about speech and dialogue mining.
Okay, Fred, thanks very much. Okay, so it's been a number of years, and I guess I've given a number of talks here on how may I help you over the years. And since over the last couple of years it matured, our interest started to change, and we started to look more at what can you learn by watching the execution of these systems, and in particular, what can you learn about your business, about your customers, and about the systems themselves. So, in particular, what we want to focus on is mining customer interactions. Yep?
You have become the screen.
I have become the screen? That's bad. Let's see. Is that better? Okay, let me try sliding over here, unraveling the wires. How's that? Better? Okay, good. So the idea is that given any small business, if you're a small businessman and you run your own shop, the people who come in every day, you know who they are, you know when they last walked in, you know what they like to buy, you know who their brothers and sisters and aunts and uncles are, and you can deal with them on a personal, friendly basis. Customer care is one of those things that doesn't scale well for large organizations because you lose that personal touch. So something that's important for large companies is to have some way of understanding how our customers are interacting with us in a variety of ways. And many of these interactions can involve spoken or written language and email, e-chat, web care, things like that, and speech when either they're talking with a human representative or when they're talking with an automated system like our How May I Help You work. And a key idea that's going to be a theme throughout this talk is that the data that we're getting on customers and their interactions is heterogeneous. It's not just speech. It's not just stuff that you can derive from speech. We know all sorts of other things, like you called us from this phone number at this time. We know how long you've been a customer. We know what your calling plan is. We know you called last week to complain about something. We know that you never call us and bother us, so if you're bothering us now, it must be for a good reason. All sorts of things. So it's not just speech, it's speech and data, and how to treat this heterogeneous environment is something that the speech community, I think, hasn't paid enough attention to. The other issue is that the data is about interactions, and interactions are more complicated than a sequence. Okay, so a dialogue or a sequence of transactions over time is not just a sequence. A dialogue, as you all know, is a turn. You do something, I do something. What we do involves speech, involves language, involves databases. How do I deal with this dialogue trajectory, as we've come to call it, or transactions trajectories? And the whole purpose initially was to close the loop between the execution of these natural spoken dialogue systems that we've been fielding. And we have about a dozen applications out there now. Other companies have their own versions, with better and worse qualities, depending on your opinions. But how do you know what they're doing? Okay, and how do you identify hotspots? How do you know when they're doing well, when they're doing badly? How do you know when things are changing, either because of what your customers are doing or your competitors or you? Okay, how do you get this information and use it to drive what happens next in the system? What we observed was, as we were learning things along that line, we also learned lots of interesting things about our business and about our customer population, which I'll share with you in a sanitized form by basically taking the numbers off the axes so I can share it, and it's kind of interesting stuff. So some examples. Examples involving speech are speech messages. Okay, very often you call somebody, and instead of getting a person or even an automated system, it just says, please leave me a message and I'll call you back. You know, leave your name, your phone number, and what the problem is. These are help desks, right? So one kind of customer care involves just a plain leaving message. There's no dialogue, no interaction. It's a 30-second to 1 minute spoken message. Then you have the situation of people who call up and speak with our human reps, okay? And that can be a 5 or 10 minute spoken conversation where hopefully something good happens and the customer's requirements get satisfied. And that's a speech dialogue between two parties. And then we have the automated spoken dialogue systems that many folks have worked on. And the two broad families are the machine initiative with highly constrained language, where you have to say the right things to get it to work, and the user initiative, where you can sort of say more what you want. And in the early days, we were thinking of it as a, let's see what happens if we let people say what they want. And then as time goes on and these things have matured, we've come to understand when different aspects of these initiatives are better or worse. So for example, if you go back, more than a decade ago, AT&T deployed a national system which still handles hundreds of millions of calls a year that basically please said, after you dialed an operator-assisted call, to 0 plus a number, and it wanted to know how you wanted to bill it, and it would say, please say collect calling card, person to person, third number, or operator. And you'd say one of those 5 words, and there was word spotting in there, and it was very nice. And I can list these 5 words for you, and you would in general understand what they meant and be able to echo back to me the one that was your right choice. Well, there are some lists of things that if I tried listing them for you, it would get quite out of hand. But you can still do machine initiative with classes. So for example, when you have a system like we and other folks have deployed that say, please speak your credit card number. Well, a credit card number is 16 digits, so there are 10 to the 16th utterances that you could respond with. I'm not prompting you with a list that's 10 to the 16th long. I'm describing to you a class in a simple sentence that you can understand and then know what a credit card is. Similarly, when you have systems like please say your destination city for train or airline travel, there can be hundreds or thousands of destination cities or people names or dates, but I can prompt you for them with a simple utterance that you'll understand. Then you bump into scenarios and applications where there's a list of dozens of options that really I couldn't describe to you in one sentence. And you hit the catch-22 of if I describe them to you in excruciating detail, you fall asleep after option 3. If I try and make them hierarchical, you can't figure out what to pick. And if I make it brief enough that you can listen to it, then it's ambiguous and you can't figure out what's going on. And that's when user initiative is a useful technique, and that's the basis for the how may I help you applications. Okay. So I'll say a few words, because how can I possibly give a talk without having a how may I help you slide in it, to remind you folks about things that I've talked about in recent years. The basic idea was that if I had a system like our customer care, where there were 49 identified services that people might want, and I couldn't possibly list them for you, but if I said, how may I help you, and listened to how you answer, I could recognize and understand and classify what you wanted well enough to determine what you want and route the call, and to route the call either to a machine, if it was appropriate for automation, or to a human expert. So for example, a sample audio clip that some of you have heard before.
Yes, I'm calling regarding my bill. I just wanted to make sure that you received my payment.
Okay, so that's an utterance that has to do with the functionality in the account balance module, which will tell you when we got your last check and how much money you owe us and all that other stuff. Okay, and that's down in the lower left-hand corner. Some people ask about calling plans. Some people ask about signing up for local service. Does AT&T offer local in Maryland? Not yet? Okay, in about a half a dozen states we do. If you call up about local, well, you wouldn't be calling from Maryland for local. Okay, and since that's a sales opportunity, they don't want to send it to a machine. They want to send it to a person who can sell you as much as you're willing to buy. So that's why I have a little picture of a machine and of a person there. Okay. And this kind of system has been deployed for customer care and half a dozen to a dozen commercial applications for other companies. Some other examples, and this is to sort of give you a feeling for the difficulty of the classification problem, because at first you say classification sounds simple. First comment is that people always find, no matter how hard you work to make a list, an ontology, a categorization of what people are going to do in the real world, there's always something that they ask for that's not on the list. So you hit phenomena like this.
I want to know what's going on with these lines. I mean, I tried yesterday to get out, and they told me that the circuits were...
That goes on for a while. And clearly you don't want to route that lady to a machine. You want to route her to your sweetest talking agent. Okay? Another phenomena that happens is that very often, both in human-human interactions and human-machine interactions, when the task is complicated, people have opening conversational gambits in which they're vague. And they do things like...
Hi, I have a question on our AT&T our bill.
Okay, is there people able to hear that? So that just says I have a question about my bill. That pins it down to about 20 out of the 49. So they did give me at least one bit of information there. But if I'm going to get any further, I need to ask questions and narrow it down. Okay, so rather than delving into the details of how we and other folks do these things, because we've talked about that in the past, what I want to talk about is how do you, and I was searching for the right verb. And at first I had characterizing customers' language, and then I had modeling, and then I changed it last night to tracking. I'm not quite sure of what the right word is, but what you want to do is you want to know the kind of language that people are saying to you, what kind of words and word patterns they're saying, and if it changes in any significant way, you want to know about it. You want to alert a person. So if people suddenly start calling up tomorrow and saying, hey, I got this great offer from Verizon, can you match it? Well, they weren't saying that yesterday. I want the machine to go, excuse me, folks, here's this new kind of question that's coming in, and it's not just a onesie, there's a whole clump of them, and here's something that changed. All right? And given statistical language modeling techniques that can vary over time and search for trends and discontinuities, there are methods of attacking that. I'm not going to go into that in a lot of detail, but for example, one thing you can do is track utterance length, how many words in a sentence, if people are suddenly getting more or less verbose. So for example, in the customer care task that I described, so there's the number on your phone bill, one way of characterizing the language, which is rather simple-minded, but therefore I can fit it on one slide, is how many words are in an utterance. And you tend to get these chi-squared looking things. The mean is about 40 words, okay? And you get the distribution that I showed you. If I look back at the operator services task, which we've talked about in the past, so that instead of being customer care is what people say when they hit 0. So that tends to be questions not about your phone bill and calling plans, but rather I want to make a collect call. How do I, how much does it cost to call Japan? What time is it there before I wake up my friend? And so on and so forth. So the vocabulary, the grammar, everything about it is simpler. We've quantified that in papers. You get a shorter sentence length, a lower complexity, a different language model. And you'd like to track this over time. Okay, so that's a whole open arena, if you will, of how do I track and model that and alert the business folks and the user experience folks when things change. Another thing that you can do is track customers' intent. Okay, so we talked about intent classification. 49 different types of services for customer care. I think the number was 15 for operator services. Well, again, I can track those distributions. And for example, I have here the distribution for operator services, which is a 15 class problem with an entropy of a little over 3 bits, because it's highly skewed. Everybody here took information theory, right? Who was teaching that course? Somebody told me? Okay, so if you learned it from Sanjeev, then you know what 3.2 bits of entropy means. And in customer care, there's 49 options and the entropy is a little over 4. Well, those things can change over time. So for example, if you go back 2 years ago, when the FCC said that all phone companies had to charge a universal access charge in order to subsidize rural telephony. So we and all the other phone companies added a $1.95 charge to our bills. Well, guess what happened? You add the charge to your bill, you got a spike. At one point, 7% of the phone calls to customer care were just going, what is this $1.95 charge? Okay, and we answered them. And then, of course, there was an exponential decay in that, because once people ask that question, they don't ask it anymore. A few months later, the FCC said, well, okay, you've been explaining to people this, and you've been explaining to them something else called threshold billing, which means that if you only spend a little bit of money, we'll send you a bill every 3 months. So you get people calling up and saying, how come there's 3 months worth of charges? And we'd explain to them, of course, you don't spend very much, it's not worth sending you a bill every month. FCC, after a while, said, okay, you could do that, but you have to send all these millions of people a postcard. This was after we had these spikes of answering the questions, saying, if you don't like it, you can call us and ask us to stop doing it. So of course, that stuff came in, and from the recognizer and classifier's point of view, that was close enough to saying, what is this thing? That it just classified it as that and told them what it was, which wasn't what they wanted. So something that could do change detection and tracking would have been quite useful. We sort of caught it in some monitoring sessions, but you need automated procedures, not just people sitting around and listening. What are some example dialogues? So we talked about language, we talked about the meaning, then there are interactions. Okay, so I'll play you an example interaction.
AT&T. How may I help you?
Good afternoon. About 2 months ago, for some unknown reason, my long-distance charges came out with AT&T. Okay? Am I talking to a person or a recording?
You are talking to an AT&T automated assistant. You can speak naturally to me. Just briefly tell me what I can do to help you.
Okay. I was wondering, could I get my regular phone bill changed to AT&T?
Okay, so that goes on for a while. So the idea is that there's this interaction and changing and meaning, and people have actually asked me, what percentage of the time, even though we say, hi, we're a machine, do people realize that we're a machine?
Well, you didn't say hi, you are a machine.
Right.
You tried to
You said hi.
Right.
cover it up, right?
Actually, in that case, we did a sparkle tone, AT&T, and what we actually changed it to, because of that phenomena, which didn't occur very often, was something like this.
AT&T. I am an AT&T automated assistant. You can speak naturally to me. How may I help you?
Yeah, I've got questions on my billing.
Okay. What is your question?
I've got 5 charges on my long distance that were in August, and I don't know who they are or what they are.
I can help you with that. Are you calling from your home phone?
Yes.
Okay, I'll stop it there. Now, so there we said, okay, because there were this small number of people who were going, who are you? What is this? Our user experience psychologist friends said, you really have to get more explicit. So we did. Did that lady know she was talking to a machine at the beginning? Didn't sound like it to me.
Why would you say directly, you're talking to a machine?
You're hiding that one.
Focus on making like.
Yeah.
People don't like that.
For
Yeah.
They don't want to like it.
Well, I absolutely dislike this mealy mouse tone. And I deal with it when I try to get a ticket on Amtrak. Because
Right.
she, quote unquote, she says I'm Julie. Even. and
That's an
it's
African,
just
that's
terrible.
Yep. Yeah, and I think there's.
And she can't
Yep.
stop talking.
Well, this one, if you interrupt it, it stops because it has margin. But I think this is a whole open area in dialogue analysis, which says, okay, you clearly want to tip your hand. If you tip your hand in an extreme, at one point in the early days, we tried playing a really lousy synthesizer, going, hello, I am a machine, and beating people over the head with it. And you know what they did? They hung up. Yeah, they hung up, right? So there was sort of this set of experiments in the early days of trying a range of ways of tipping your hand, balancing between setting expectations and getting people to actually talk to you, because if they don't talk to you, then it's a failure too. And if you look at that, what was interesting was that the range of options led to various fluctuations in the middle of the dialogue, but the overall success rate was about the same. But it went through some confusing points and some hot spots. And what we did was we were using some dialogue analysis techniques, okay, which are in their very rudimentary stages. People who do computer security tell me that they're much further along on modeling interactions between entities than we are in dialogue. But if I'm in the situation of having millions of dialogues per month, and then when I get more applications, I have even more data, I can't possibly listen to them. And if somebody says, so tell me how they're going, I played you an anecdotal example, but if I have millions of these things and I want to try out 500,000 with one opening prompt and 500,000 with another, or 100,000 of each, the machine ought to be able to try out these 10 different options at 100,000 options each over the course of a day, and then tell me how they went. Well, but how do you tell me about millions of dialogues? Okay, if it's millions of numbers, I know what to do. If it's millions of, that's an undergraduate statistics course. If it's millions of sentences, that's a graduate language modeling course. If it's millions of dialogues, we're at a bit of a loss. Okay, and there are some ideas where you can project it down onto simpler structures. And what data mining is all about, as I've said, is discovering unexpected patterns. Well, that implies the necessity of learning what are the expected behaviors of things as complicated as dialogues. And you can view mining as testing the null hypothesis that things haven't changed. So you can do things, for example, like take prompts and collapse them together into equivalence classes, impose a notion of state. You can take answers, collapse them together into equivalence classes, impose a notion of oval state as opposed to rectangular state. Is this the right way to do it? I don't know. And then you can start looking at trajectories through these things. And this is a diagram that basically says, well, some percentage of people hang up, and they're actually national statistics, and that's well within the norm because the doorbell rings, or the kid starts pulling the dog's tail, or your boss walks into the office and interrupts you, and things like that. But what you do get are you get statistics on, for example, from the top prompt, how often are people specific, which is 58% of the time, versus how often they were vague, which was 27%, roughly a 2-to-1 ratio. Okay. You can then say, well, if I said something non-informative or was silent, non-informative might be good morning, hi, my name is Al, doesn't tell you what I want. Then I'm going to say, I'm going to do a reprompt that says, hi, please tell me what I can do for you. And then the ratio of vague to specific is about 3-to-1. Okay. If after you said something vague, like I have a question about my bill, if I say, so, what kind of question about your bill do you have? Get to the point. That's a clarification. And then people are specific to vague And you might even ask, how can they still be vague at that point? And they say things like, well, I have a question about a charge on my bill. And you're going, there it's affordable. So one of the things that we were able to do was we were able to experiment with different wordings of the prompts, okay, and then see how the transition probabilities moved around. Okay, and the idea is that you wanted to shift things away from non-informative responses or questions like, who are you, what is this? Okay, and by shifting the prompts in a sequence of experiments, we basically made the oval node that was, who are you, what is this, disappear. Okay, the transition probability to that was 0. The completion rate stayed about the same. So from a task point of view, it didn't change, but from the interaction point of view, it changed. Okay, how to carry this forward, I think there's a lot of open questions. Now, I want to say a few words about that point that I was bringing up earlier, which is that when people are talking to us, we know much more about you than what you're saying. So for example, if you call up and say, hi, I want to arrange payment for the bill, for my bill. Well, if Fred calls, I know that he pays his bill reliably every month, so he's just looking for a way of sending me a check or putting it on his credit card. If somebody else, on the other hand, calls, and I won't pick on anybody, who I know hasn't paid the bill in 6 months, okay, because he's been busy with his broken leg, and we've been dunning him and sent him to a collection agency. When that person calls up and says, I want to pay my bill, that has a very different meaning. Okay, and you want to transfer that person to the collections group, who will do whatever they need to do about getting the police off their tail. Okay, so the same words, very different meaning based upon the other things that we know. So what I want to do is a brief exploration of what we can do with heterogeneous data like this. Yeah, this is based on work that we've been doing with Jerry Wright and Alicia Bella. Okay. So let me start out and say, well, let's take a look at a Dialog, or IVR stands for Interactive Voice Response System application, but rather than looking at it from the technology point of view, which is on the inside looking out, let me try and look at it the way the operations folks look at it. And what they say is, well, a call comes in from somewhere, there's an application, and I'm curious, how many people have ever experienced looking at a call flow specification for some application? Okay, it's hundreds of pages of circles and lines and flow graphs. Who's old enough to remember what a flow graph is for a computer program? Okay, not too many people. Okay, that's still the way they specify call flows for all of these things. Not that it's the right way, that's just the way they do it. So you'll have hundreds of pages of call flow for some complex application, and then some user comes in and walks through that, usually only through, if they're lucky, a dozen nodes or so, and that's what we'll call a dialogue trajectory. And as you walk across that dialogue trajectory, certain nodes where we do something for you trigger what people in the community call service events. That meant that we gave you some information or we did something useful as opposed to being unuseful. And then the three broad kinds of outcome that you can get are, I can decide that you really need to talk to a person at the end of all this. That might be the right thing to do, but it costs me money. I might send you off to somebody else's IVR or automated system, in which case if they send you a rep, it's their fault and they get charged for it, not me, which is a local optimization, or the person might hang up. Okay? Now, sometimes it's good that a call terminated in a hang up. So if you called, you asked some questions, you got what you wanted, that's a happy hang up. If you called and wandered around for 15 minutes, didn't get what you want, that's an unhappy hang up. How do you distinguish between them? The way you distinguish between them is by looking at the dialogue trajectory. Okay, you have to look at what happened. And so you distinguish between happy hang-ups, which people call completes, and unhappy hang-ups, which they call abandonments, by looking at what happened in the dialogue trajectory. And the models of what goes on there in operational systems tend to be very simple. They tend to be just flags that are on or off. So they can't distinguish, for example, between I called up, asked for my account balance, you gave it to me, I said thank you and hung up. I triggered the service flag of you gave me my account balance. Versus I called up, asked you for my rate and calling plan, you gave me my account balance, I wandered around for 15 more minutes, hung up and discussed. Well, that's the same unigram distribution. They can't tell the difference. So you clearly need better models.
So the dialogue trajectory is a marked point pattern?
Yes, so it has history and the whole thing. Okay. Now another thing that we know is we know where the phone call came from, because for a specific application, there can be dozens of different 800 numbers that get routed to the same automated system. Don't ask me why. This is just the way the world is. Okay, so we know where you came from. Annie is automatic number identification, so we know what number you're calling from. If you're calling from Johns Hopkins, I may not actually get your office extension. I may just get the PBX. So there are parts of the network that are invisible to us, and everything from that part of the network that comes in looks the same. Okay, and there's interesting things that you can do there that I won't talk about today. But I also know your account number, what 800 number came in, and then given your account number or Annie, I can use it to look up in the database, what segment are you? How much money do you spend a month? What calling plans you have? How long have you been a customer? A whole database of stuff that anybody that you do business with knows about. So this is the picture. And if I want to pose myself a general problem of saying, hey, I'd like to understand what the correlations are between callers, what they say and how they say it. And in general, I have 3 bins, which people usually work on in isolation. I have the spoken dialogue with all the speech and interaction there that we love to model. I have the call data, which says when the call came in, from what number, how long did it last, things that we would use for billing. And then once I know who you are, I have customer profile data. Okay, and each one of those has a lot of information in it. Let me take a particular example and work it through of saying in particular, well, one of the things that I can measure from a spoken dialogue is caller intent. What you wanted, that's by the understanding and classification. Something that I can measure about the call itself without knowing anything else is how long did it last, how many seconds or minutes. Something that I can measure about a customer is a caller segment, and there are various dimensions of this in different, some say, how much money do you spend a month, for example, and that's the one that I'm going to use. Okay, but I'm not going to put actual dollar figures on. So what am I going to do is I'm going to first look at each one of those 3 axes from those 3 sets of data individually, caller segment, duration, and intent. Then I'm going to look at the question of, are these distributions independent? Okay, well, if you took a statistics course at some time, you know that there are statistical tests for how to do that, and there are various degrees of fine-grainedness of it. The most fine-grained version is a contingency table, which is in chapter 1 or 2 of most of your textbooks, and it'll tell you, is there a significant dependency? Okay, and you look at it in terms of adjusted residuals and so on. So I'm going to look at a pairwise contingency analysis, but I'm going to simplify it for you so that it looks prettier. And then I'm going to ask the question of, well, gee, given these 3 relationships between these 3 boxes to any extent that there's correlations, am I in a situation where 2 of them explain the third? So the third one isn't real, it's just a result of the other 2. How do you answer questions like that? It's called a 3-way contingency table. Okay, so for example, caller segment distribution. Okay, so I changed the segments into low, medium, high, and very high. And you can all use your own imagination and decide what the dollar figures are associated with that. And then we have percentages there, and it actually doesn't add up to 100%, okay, because there are some segments that are excluded from the system. So you can't do any reverse engineering. But what it does tell you is that the low and medium are sort of higher volume, and then the higher value and the very high value are lower volumes, but higher value. So doing more for those smaller populations might be in my best business interest. And there's enough data in this so that everything is significant to within a percentage point or two. Sigma is under 1%. I can look at caller intent distribution, and a point that I want to make here is I can look at the manual labels, which is the kind of thing that I showed you before. But getting manual labels, which is a human judgment of what all these millions of people wanted, that's impossible. You know, I can start taking random samples, it's a lot of work. How about if I look at the output of the spoken language understanding or the dialogue system, which I know is not perfect, but is up in the mid-90s, and I kept the rank order the same, and what you see is that there are differences. Now, an interesting observation, because we started saying, okay, now how do I work with this? Because I can't do change detection and monitoring on manually labeled stuff. That's prohibitively expensive. So I have to do it on the output of the machine. What's the relationship between these two things? Now, my first inclination was to say, oh, this is a noisy version of that one. But then, if you're in the situation with a lot of data, there's actually a relationship between those two, which is called the confusion matrix. Okay, so when I have a lot of data, and I can estimate a confusion matrix, the relationship between the manual and the automatic labels, and here I struggle with the PowerPoint version of equation editor. It wasn't easy. I'll get scientific word from you. Which basically says, well, if I take the distribution of estimated labels and the distribution of truth, the relationship is a matrix multiplication. So if I have enough data to get a good estimate of the confusion matrix, and I have enough data to get good estimates of those histograms, and for example, down at the 1% point of those histograms, sigma was on the order of a tenth of a percent. There's tons of data. Right? So that actually says, oh, there's this almost deterministic relationship between the truth and the output at the distributional level. So I can go backwards. Okay, and I can do change detection on the system output. Now, of course, in all these, I might be able to get enough data to fill out the tails of the classes, to fill out all the tails of the confusion matrix. I'm sure there's going to be small sample statistics there that are going to come into play, so there's still going to be noise. And how do you handle all this and know when you can do it and when you can't? That's a question that we're working on. Okay. Third dimension was call duration distribution.
I'm sorry, I want to ask a question.
Sure.
You are taking the manual classification as 100% accurate, but there's presumably error in those as well.
That's right, yep. Yeah, and we've done experiments on evaluating the human error rate or the human disagreement rate in labeling, and it's on the order of 5% or so. So the magnitude of the human error rate is pretty close to the magnitude of the machine error rate, which makes me feel good, but the error patterns are not the same. Okay. Okay, so it's not quite as good as I would like it, and for those people who work with perception and look at error patterns on phones, you don't just want the error rate on phones to be the same as humans, you want the error rate on phones or something to have the same pattern. So it's not quite there yet. Okay. So for duration, average time is on a log scale, so this is 10 to the 1, 10 to the 2, 10 to the 3. The mean duration in automation is about 2 minutes, including the intent classification and the service. Okay. Now let's take a look at some pairwise ones. Well, pairwise, if I plot mean call duration versus segment, I see this declining distribution there. So I say to myself, Does that mean that the lower value customers talk more slowly? Or punch buttons more slowly? That doesn't make any sense to me at all. Does it mean that the higher value people talk faster? I'm not convinced that this is a real dependency. It's a correlation, but I'm not sure that it's real. Okay?
Well, the high people don't have time.
Yeah, it's
Those guys, they get to the point much faster.
Right.
These do it in
Right.
business
so
as opposed to a personal
that's right.
communication.
Right, so there's all sorts of possibilities. So maybe there are some deeper reasons why it should be true, or maybe it's just a statistical correlation with no cause and effect at all. I don't know yet. Now let me look at another pair. When I look at the pair that says caller intent versus customer segment, what I did here was I picked out 6 out of the 49 categories where the deviation in the contingency table was more than 3Z, where Z was the adjusted residual. So I'm not going to show you the contingency tables and those analyses. And basically we get things like, well, the black is the overall, and then this is low, medium, high. So what it says, for example, that with people asking questions about unrecognized number, the low value customers are asking more often than average about unrecognized numbers on their bill than are the higher value people. They might be more concerned about the money than the people who spend more money. People who call up to arrange payment, automated payments on the bill, tend to be more often than average the higher value people. That makes sense, okay? Account balance, the higher value people are calling more often than average about their account balance. I guess when you owe more money, you're more curious. I don't know. Disconnect, which says I don't want to be your customer anymore. Okay, that's a bad one, right? Well, the higher value people are calling way less than the lower value people, and I hope that's on purpose due to some marketing campaign that we managed to retain the high value customers as opposed to chance. But these are the kind of questions that come up, as well as the questions that you raised. Okay, so I think one of the things that we see is as you look at these things and you start searching for explanations, you immediately come up with another set of plots and graphs that you want to do. And maybe that's why they call it mining. After you dig, you want to dig some more. One final one, pairwise, says that if I look at caller intent versus duration, and I broke up duration into just short, medium, long, where the average before was 2 minutes, for people who have an unrecognized number on their bill, they tend to spend a lot of time in automation. Why? Because we have automation for that. We say, oh, fine, there's a call to Chicago you don't know about. Tell them me the number, I'll look it up for you, I'll tell you who it is. If you don't know who it is, I'll take it off your bill. People who want something that isn't on our list, well, we're really good at telling when you want something that's not on our list. That's the rejection problem. And you spend very little time in automation, and we send you right off to a person. Okay? Same thing if you want to disconnect. Okay, if you don't want to be our customer anymore, we figure that out really fast, and we get you out of the automation and send you to a person whose job it is to talk you out of it. Account balance, since that's automated and it doesn't take too long, tends to take shorter. Okay? So these are some relationships that make intuitive sense. So now let me pose the question that we raised before that said for the dependency between caller segment, how much you spend and what you want, I was sort of able to make sense out of that. The relationship between what you want and how long you're going to spend in automation, that makes sense too. That one that we were a little fuzzy about was the relationship between segment and duration at the beginning. And you can ask the question, which is a conditional independence test, of do these two predict that, what we saw. And I'm not going to put up a 3-page, three-way contingency analysis for you, but it's basically a conditional independence test. And the answer, interestingly enough, was that in every cell of that 3-way table, the answer was that it was conditionally independent. Those two explained it except for one cell where there was a dependence. And that cell had to do with when you were in a low value segment and you were saying, I want a person, I want a person, I want a person. You were less likely to get a person than if you spent a lot of money and said, I want a person, I want a person. Why? Because the folks who built it that way. Not that we would ever do something.
Did you know that before you did the data mining?
I had sat through some discussion of it, but it had sort of slipped my mind. When it came out, we sort of said, oh yeah, right. So the idea is that one can do graphical model analysis and start saying, well, where are their relationships? Where are they real? Where do some explain the others? And so on and so forth. And from this, you get business intelligence, information about how customers behave, and lots more questions to do some more digging. Okay. Let's see. 10 minutes. Okay, so now what I want to do now is switch gears and talk about some tools that we've been building for allowing people, users, user experience people, business people, to browse and access these various types of spoken communications. Okay, and the three broad families that I talked about were voice messaging, which might be a message in my personal voicemail box. It might be a message at a help desk that business customers call. Okay, and those are characterized by being single speaker and short duration, on the order of a minute, give or take a little bit. You know, your voicemail box usually cuts you off after a minute or two, so the average messages tend to be 30 seconds or so. The next level are human-machine dialogues, like how may I help you, which again are single speakers, but there are multiple turns in a dialogue and life is more complicated. Okay. Third dimension is when I have conversations between multiple speakers, and this shows up in customer care. So you're talking to a rep, we want to do quality control, make sure all the reps say thank you for using AT&T at the end. There's actually some people working on applications of this to telemarketing, but I can't stand telemarketing, so I'm not going to say anything about that. And also for teleconferencing, AT&T provides teleconferencing and bridge services, and one thing that many people would like, and we were talking about it earlier, is the ability to record your 1-hour teleconference meeting and keep track of who's saying what and be able to search and index it. And these are multiple speakers, longer duration, can go on for an hour. So I want to talk about 3 tools very briefly that our lab has been working on, and there's a half a dozen people associated with each of these. So if anybody wants more information, I'll be happy to point you in the right directions. One system is called ScanMail, which is targeted at browsing and searching voice messages. Okay. Another system is called Animate, which says when I have a collection of utterances, either from voice messages or from how may I help you type systems, and I want to figure out where these 49 classes come from. Okay, well maybe should there be 52 or 48, and do they have the right names and the right definitions? How do I discover and impose the structure on them? And Animate is a tool that we've created for accelerating the process of discovering and imposing the class structure. I'll get to the details in a second. And then when it comes to conversations between multiple speakers, like for teleconferencing or analyzing customer rep interactions, Speech Logger is something that we've created for browsing and searching these dialogues. So ScanMail was motivated back a few years ago, and you probably heard talks by Julia Hirschberg and Steve Whitaker, who were the pioneers on this. And it was motivated by user studies identifying bottlenecks for voicemail users. So you all know that if you had 8 voice messages, it's really hard to quickly scan them and figure out what you want from them. If you know that there's a particular message that you've been waiting for, you literally have to step through everything. It's a voice is a sequential access. And if somebody leaves me a 1-minute message and I just want their callback number, which they say really fast at the end of the message, I have to listen to it over and over and over again, and it kills me. Okay. So this is an interactive tool for browsing, sorting, and searching, providing random access, and giving an integrated view of the audio plus the non-audio metadata or non-linguistic data, like call or caller information.
Actually, this is for you. This is not for the customers, right?
Actually, it's for customers too. Yeah.
I see. So one of these days, you will supply me
Yes.
with methods to skip people's messages.
That's right.
And not erase them and not go
That's right.
sequentially,
Yep.
etc. I see. Okay.
Okay. There are definite plans to do good things with us. Okay. Oops. What happened to my pictures? Hang on. I lost my diagram. There we go. Okay, so here's a very simple image of the scan mail screen. Basically what it does is it converts your voice messages into email. And what you see up on top is a list of the caller, and I'll tell you how we get that in a second. The size of the file in seconds, the telephone number, which can be a 4-digit extension from within the company, in which case we get caller ID and it pops up. If it's an external call, we can go to Anywho and look up the number, the name, and attach that. Right? Also date. And what we can also do is when it's an external call, and I guess you can see it, there are 2 calls from Aaron Rosenberg in there. And if it's an external call where we have no information or no caller ID information, then it does a speaker ID against the population of people who have called me in the past where there are names associated with it. So it builds speaker ID models.
I see. So the Julia Hirschberg identifier comes from the fact that we know that 8330 is a number.
It's Julia, right.
So you jump to a conclusion, so to speak.
That's right.
Right.
Yeah, and I guess a comment that I want to make about the way this is done is when there's a number, we just jump to the conclusion that it's Julia because that's the caller ID. When it's external, we use voice print. It could have been Aaron calling from Julia's office. What you really want to do is to say, well, you know, I know the distribution of people who might call from that number. I know the distribution of people who call me, and I have an acoustic signature. How do I combine all that information to come up with a decision? That's what you really want to do. That's not what we're doing right now. Okay, but that's in line with this heterogeneous exploitation. Over here, you have the ASR output from the system, which is running at about 80% accuracy, not real time, because voice messages don't have to be real time. It can take a few minutes. And there's a separation based on some clausing and pausing analyses. Again, the accuracy is about 80%. One of the things that the system does is it does information localization. So things like phone numbers, or this is Al, it'll highlight phone numbers, it puts little phones around it. Names, it puts little smiley faces around it. I'm not convinced that's the best way of doing it, but what it does is it gives you a random access way of going to the audio message. You don't have to play the whole thing. You can pick a piece of it, highlight it. I'm sure IBM Via Voice had things like this too, and do random access. Also, as you go down, if you look at the one that says Aaron Rosenberg 40 seconds external call, if you roll the mouse over the little symbol that is under highlights, what it does is it gives you any numbers and names that were extracted so that you can see, I'm not sure what 10024 is. It's either a zip code or a purchase order number, and the other one is his phone number, okay, which he said call me back at. Okay. So this is one kind of tool, and you can use this for browsing voice messages. We also use it for browsing how may I help you data, okay, because this way if it's a 30-second utterance, I can go on. What Animate does is give us a way of interactively defining the ontology of these classes, and basically it's an interactive tool for generating and editing clusters. So rather than saying I have this whole list of things, somebody writes down a guidebook, I go through and I label them. It does a clustering. You can then edit the clusters. You can move whole clusters around and put them into classes that you want to use for an application. And the way that looks now is you have a primary cluster over on the left, and you have a secondary cluster, which is the closest cluster to this. That's not the same thing. And then you can edit either as a chunk or individually and move things around. Okay, speech logger is the issue of, well, if the thing's an hour long, I certainly don't want to show you an ASR output of it and give you random access to it. That would be kind of not useful. So how can I provide a thumbnail overview and access into these things? And I guess the way we always used to do it in the past was we call up waves and look at a squiggly line, which would go on and on and on and on. But there are better ways. And what you can do is you can get a segmentation by speaker. This is actually not to teleconferencing data, but to the NBC Nightly News. You can do keyword searches, so you can search on speaker, search on content words. I can say, find me the part in the conversation when Fred said, don't do that anymore. Okay.
Which time?
And then everything would light up. Okay. So in conclusion, what I've done is shared with you some work that's in its early stages in bits and pieces, which is talking about methods for deriving business intelligence from heterogeneous data, which has speech, caller, and call detail. We applied it to some of the How May I Help You natural spoken dialogue to learn some things about it, and shared with you some interactive tools that we've been developing for providing user interface folks and business people access to browsing all these things. That's it.
So among the data that you might collect, besides the ones you mentioned,
Right.
are any emotional content or other super segmentals. So are the people angry? Are they hesitant? Are they confused?
Right.
I don't know. Have you looked at any of that? Is it likely to be useful?
The answer is we've looked at it a little bit. It seems like it would be incredibly useful. We actually have a couple of people who do prosody type analysis. And for example, a trajectory that says this person is getting more and more upset during a dialogue. This is useful information in identifying what we call problematic dialogues, where you either want to change your strategy or bail out. The phenomena of people who start out with, I have a question about my bill. Okay, somebody who knows they're talking to a machine, and then you go, okay, what kind of question? They go, well, you know, it's a question about, and they start talking naturally. Well, I'd love to be able to, I mean, people always ask me,
how many people are doing that?
how many people, you know, are going one way versus the other way versus never seem to have a clue that it's a machine? What's going on there? All these things, yes, incredibly useful. And I guess the biggest obstacle is while there's been a lot of work in the community on prosody extraction and emotional analysis, it tends to be on toy databases. You know, we had a workshop up in New Jersey a couple of years ago that Julia and Marie Ostendorf and others sponsored. And a lot of the analysis was on fake data, where you say, here's a cookie, say something angry. Here's a chocolate bar, say something happy. Okay, you know, here's, you know, a sour grape, you know, act upset. And you collect this and you do your analysis. We actually have not many examples of upset people, but lots of examples of people who get happier and happier throughout a conversation that I'd like to do the prosodic analysis on. So the answer is yes, that's a very important future direction.
You could do it not only for the data mining part, but also online.
Yes.
If they're getting
That's
angry,
right.
you might want to send them off to a
That's right.
human person.
Yeah, and the online part, there were a sequence of papers that Lynn Walker and Jerry and I wrote a few years ago called Problematic Dialogue Detection. And the basic idea was if you and I are having a conversation, we're really good at figuring out if it's not going anywhere. While machines, you know, as Fred said, they don't have a clue. You know, it can be going nowhere really fast, and the machine just happily, merrily goes on its way. Well, the machine ought to have a way of knowing when the dialogue is converging or diverging. That's what we call problematic dialogue detection. What are the clues to the machine that it should either change its strategy or bail out to a human? Important question.
Did you have focus groups on all this? Well, I mean, I'm thinking again
Yep.
about my unhappy experience
Yes,
with Amtrak, all right?
Right? Yep.
I mean, what happens is that if you make a mistake, you can't go back.
Right.
Julie immediately sends you to some agent, but of course the agent is busy. If you got him immediately, that would be fine.
Right.
But all right.
Yeah.
So there are all sorts of things that that
Right.
I object to, and
Oh yes, yeah, and there's a lot of work to make these things better. And one of the things that we've been pretty happy about with this technology is, on the whole, people have liked it better than not. The number of customer complaints, which the corporation measures, so we measure the number of complaints about customer care. The executives get complaints, the FCC gets complaints, and the state public utility commissions get complaints. And as we ramped up How May I Help You, the number of complaints went like this. It was so dramatic, it went down 78%, so it went down by a factor of 5. It was so dramatic that the executives involved wouldn't share it upstairs until they watched it for another month or so to make sure it was real, because they had never seen anything like it before. So that made us feel pretty good.
I just had another problematic dialogue
Uh-huh.
with Verizon this past week. And they just distributed...
Well, that's BB&N's fault.
Well, I'm not sure who did this one. So got a phone call, my answering machine, the light was blinking, come home. Because they had just distributed new phone books last week. It says, this is the automated Verizon dialer wanting to see, we distributed phone books. If you received it, press 3. If you didn't receive it, press 9. Of course, the answer machines get it. Then it says, thank you for your response. I haven't played it a couple times. It's making it harder and harder each time I listen.
That's pretty good.
Yeah,
Yeah. I like it. Jack?
I want to go back to Jason's question. What I hear you saying is, yes, we're interested, yes, we looked at this, yes, we'd love to know that, but are we at the stage where we know anything systematic about, or even a catalog of features that characterizes people who are angrier than they were the last audience?
I am not convinced that we are. I think there's been a lot of work. A lot of it's been anecdotal.
When you say a lot,
I wouldn't think it's a lot.
Well, a lot in the sense that we filled up 2 days.
A lot of talking about it.
Right, a lot of talking about it. I'm not convinced that we have the solutions or the knowledge for that problem, to how to solve those. And
There's a
I
catalog
think
of
we need
features,
it.
or
No.
because I've heard a number of conversations like this, and they always say, "Oh yeah, people who worked on that," but
Yeah, but there hasn't been the concerted effort that it needs to actually accomplish something.
I don't even know where you would start.
well, you
Well, there
probably
are-
want to do some human annotation of exactly these kinds of interactions.
Yeah,
Yeah, I think there hasn't
I mean, it might
been
be hard
any
to find
systematic
them,
studies.
But if you,
like for example, one domain-specific corpus of some size that you could look at. I don't even think we have that.
well, so I think the way to collect it actually would be to look at the conversations between humans and humans. So suppose you guys in your call center, if by the time the rep gets them they're pretty angry, you just
Yep.
ask the rep to press a little button saying file this in the angry corpus.
So who gets
Yes.
to look at that?
Well,
The research.
I don't know. It depends on how friendly we are.
The researchers who own the data only.
Yeah,
Right.
I understand.
Yeah, and I think the comment here
They're
is
really
that
doing
there is
technology development.
right is that there's a lot of sort of private corpora about problems like this. I remember there were some experiments done by Elmer Knott on Vermobile, where he showed how to use prosodic brakes and stress to actually accelerate parsing, improve and accelerate parsing. Okay, which I found interesting. And if you think about it, it's, well, people don't go 90858 to 2778. There's certain intonational contours at various breaks, and that can help accelerate things. That was nice, but it was on some private annotation, and there was no public corpus of real data that people can do competitions on and propose features and do all the same things that we've done in speech recognition, speaker recognition, language ID.
Well, I think what has to be done is for some funding agency to strike a deal with somebody who would be willing to release these data under some circumstances collectively.
Well,
so not somebody who's in the field like AT&T, but say a mutual fund company or something. Well, maybe something with less confidential data than that.
Well, one reason I approached is because I sat in a presentation not too long ago by somebody who wanted money to study this and acted as if they knew just what to do. But I don't really think that there's a corpus, and I don't think that, I'm not even sure that we know what we would want to collect.
Right. I mean, we spent a few months annotating speech for angry, neutral, happy, also age, because you can tell in some voices that somebody is elderly. And I'm told by my coding theory friends that there are quiver detectors that are out there. But there were a handful of features that we looked at and we annotated some of this data with, and you can do better than random.
See, somebody like Al, who was at the end of each sentence, could have opposite cues from someone who drops their intonation.
Yeah, that's
sense.
Yeah.
Maybe you can't do it on a sentence by sentence basis,
Right.
although it's a different contour.
Right. And for example, there's a data collection by up at MIT of somebody who's collecting spoken conversations between lots of individuals. It's one of Sandy Hetland's students, and he's looking at, I think it's an ARTA-funded project, so he's looking at things like, can you tell, if you attach a little microphone to each one of us and record everything we say during the day, by radio, can you sort of keep track of who's talking to who, do social networks, and then some of the interesting speech questions became, can you tell if you and I are having a conversation, who's asking who the questions and who's giving the answers, because that's a defining part of the relationship. Okay, can you tell who's interrupting who? That's a defining part of the relationship. Can you tell who talks more or less in a conversation? So these are sort of non-linguistic things that you can learn by listening. And again, I think it would be a good idea to do something in that area.
Yeah, you've done almost everything. Do you also?
No, not even close. Only scratch the surface.
Do you accommodate then for accents? If somebody speaks with a deep Southern accent, does the machine respond to them with a deep Southern accent?
I guess the way it works nowadays is you accommodate recognizing people with different accents by using lots of training data from all different dialects, and that goes into the statistical model so you can train. The problem of detecting that you're speaking to me in a Southern accent, or detecting that you're speaking to me in English with a German accent, so that I would respond to you in German or Spanish, which is more interesting to us. Those kind of things are, again, in their infancy. People
Probably easier to classify on the incoming area code for the application you're talking about.
Yeah.
Well, perhaps, but I mean, the fact is, what he just said was that, okay, for example, Hispanic would be very useful if somebody speaks with a thick Hispanic accent.
Right.
That you would want to respond to them in a
That's right.
friendly way.
Right. And we have work ongoing right now to create Spanish How May I Help Yous for our Spanish-speaking customers. A obvious next question is, can I detect somebody speaking English with a Spanish accent? And I think back to the experiments that we did in synthesis with Telefonica, which is the Spanish telephone company, more than a decade ago. David Rowe did this work with a visitor from there. And they wanted to build a Spanish synthesizer for simple stuff, like digits and phone numbers. So they came, and the first thing they did was they took our diphone sets, which is what we were using at the time. So English diphone sets, but put them together using Spanish pronouncing dictionaries. And not that I could tell, but the Spanish-speaking folks in the group said, oh, it's speaking Spanish with an English accent. Okay. So, can we do that for people? I would say that's a really good problem to work on. I think that would be very interesting. But no, we haven't done everything, not even close. Okay. I'm sorry.
Have you done studies also on the kind of voice that seems, I heard recently someone was studying whether a male voice or a female voice gave responses because in certain situations males didn't want to get information from female or vice versa.
I know that there's been a ton of studies done on that for what kind of applications different genders prefer different genders' voices. I don't know that literature per se, but for this work, for our synthesis work, we've actually done a lot of effort on picking voices that people like for different applications. So in the natural voices TTS system, there's a collection of voices that were chosen, male and female, with different accents in different languages, based on user analysis studies and focus groups. And what we actually did here was the voice that you heard was the voice of the primary synthesis voice that we use. So we said, let's pick the same voice that we're using for synthesis, so that if we need to add in some prompts that says, oh, that call to Chicago, was to John Doe, which I couldn't record but would have to synthesize, that it would be the same voice as opposed to switching back and forth. So there is a large literature on that. I think for customer care type things, I seem to remember people preferred female voices, and then there were other applications that they preferred male voices, but I can't remember which is which. Okay.